I hope you are good. Guys, today the topic of partial fraction, we are going to discuss the fourth and final case of partial fraction. As per rule, first we need to justify the given fraction must be proper, and if there in the denominator there are linear and a quadratic term whose factors are not possible, means unfactorizable quadratic expression comes in denominator, then you need to follow the few certain rules. Like we are doing a question here taken from policy paper. Let's see in such case what to do. This question I took it from the policy paper. Okay, here you can see the first type, the fraction must be proper. The highest degree of the numerator is 1 and denominator will be 2 and 1 3. Be 1 by 3. So it's a type of proper fraction. So it's justified. We can start it 6 plus 7x over 2 minus x times 1 plus x square equal to. In the first case, that here you can see we have one pure linear term and other one is quadratic, which is not non-factorizable, and you can't make the factor of 1 plus x square. So in such case, if you can make the factor, do factorize first and then go with the linear cases. Case 1 you will apply because all the term in the denominator become linear. But for this case, for this particular question, you can see 1 plus x squared can't be factorized to linear. So in such case, for the first term linear, you will write the single alphabet here over 2 minus x plus, and whenever you have non-factorizable quadratic which cannot be factorized further, then use double alphabet, any b with first with x plus c. We use double alphabet, first alphabet with x and the, the second without x divided by the term 1 plus whatever is quadratic unfactorizable. We wrote. So here now this time we need to find value of a, b and c. So this will be the equation 1, and this can be done with the help of converting square, and for this linear you can substitute to get a. Okay, so as per rule, to multiply each term with this highlighted denominator term, we will get 6 plus 7x equal to 8 times 1 plus x square plus bx plus c times 2 minus x. So further solve this, simplify it because we need to find a few unknown with the help of converting square. So we will expand it. A plus ax square plus when bx will multiply this entire term will be 2bx minus bx square plus 2c minus cx, right? This goes to be the equation number 2. Now what to do, as for the first uh, case, the in denominator of a we have linear terms, so you need to put the linear term that whatever be equal to 0, so x will be 2. In equation 2 we will put it, or 2, or here the same, this one is the same because equation 2 we got from after simplifying this one. So here you can see, if you replace x with the 2, it's 2 minus 2 0, so b and c all become 0, only the a will be left. So 6 plus 7 times 2 equal to a into 1 plus 2 square, and I can write b and c 0. 14 plus 6 is 20, and it will be 5a, so a comes to be 4. And for unfactorizable quadratic term like this, we never try to substitute this equal to 0, right? So in such cases, we need to do the comparison. What to do? Now compare the coefficient of highest degree in equation 2 is 2, so x square and then x. You will see in the left hand side you don't have here any term including x square. So it doesn't exist, so you can write in place of that equal to 0, equal to here a and minus b, a minus b. A already we have calculated, that is 4 minus b equal to 0, so that gives me b equal to 4 as well. Also for comparing coefficient of x, so in the left hand side we have coefficient of x is 7, and further we have minus 2b plus 2b and minus c. So we write 2b minus c, and b as we have calculated before. So do replace the value of b, you can see 8 minus 7 comes to be c, c will be 1. So these are the values. So our final partial fraction is, we have solved this after finding the values of the unknown ABC. That is the final answer. I'm going to show this now in partial fraction. 4 is 4 to 2 minus x plus what was b? B was 4x and c was 1 divided by 1 plus x squared. So that's my final answer. I hope it is clear. Okay, take another example to resolve into partial fractions. The given question is 5x minus x squared all divided by 2 plus x squared times 1 plus x. Here you can see, guys, we have one linear term and one non-linear term which is unfactorizable. You can't make the factor of this one to resolve into linear. So in such cases, the case number 4, you need to resolve or like this. It will be resolving for the non or unfactorizable term. Use double alphabet with first with the linear ax plus b divided by 2 plus x square plus, and the second case is the linear term, alphabet is c over 1 plus x. Or you can write it as, first you can write the linear in a upon 1 plus x plus, and for the quadratic this one bx plus c over 2 plus x square. Because a b c are constant, it doesn't affect. So if you label, change the name or swap the labels, it doesn't affect. So you can either write these cases square times 1 plus x. So as per rule, we have checked the fraction is proper fraction. The numerator we have degree 2 and denominator we have degree 3, so proper fraction, and we resolved with the by applying the case 4. Now whatever is in the denominator of the original fraction, multiply each term with this. So we get 5x minus x squared. When we will multiply this denominator term of the original fraction with a, we will get a times 2 plus x squared, because 1 plus x will cancel out. And similarly with bx plus c, 2 plus x squared will be cancelled out and we will get 1 plus x. Now, if this is equation 1, for this such cases unfactorizable to quadratic term, we need to expand the the expressions after simplifying this, and we get x minus 5x minus x squared equal to 2a plus ax squared plus, now bx will multiply with this entire term, we get bx plus bx squared. When c will multiply the entire term, we get plus c plus cx. So this is supposed to be the equation number 2. Now as for linear denominator, Just put that if 1 plus x equal to 0 means x equal to minus 1. So here you can see because the Pn2 comes up from this simplification. So for the linear directly I can put it here. When you put x equal to minus 1, you can see here b and c will be eliminated because this becomes 0 times this will 0. So only a will left. So 5 times 1 minus 1 square, so it's minus 1 equal to a times 2 plus minus 1 square. It's minus 5 minus 1 equal to a times 2 plus 1. So minus 6 is equal to 3a. So a is minus 2. So this comes to be the first unknown value. And now B and C left. For that, we need to go for the comparison. So by comparing highest degree of equation is 2, comparing coefficients of x2 and x square 1 by 1, x square and x 1 by 1, right? Let's see. When you compare x square first, here we get x square coefficient left hand is minus 1 and the other side a plus b. Already we have calculated a, that is minus 2, and b equal to minus 1. So b goes to be 1, right? And when you compare the coefficient of x, on the left hand side we have 5 and right hand side we have terms b plus c, which gives a coefficient x. So b already we have calculated. So replace the value of b here, c goes to be 4. So these are the four unknowns which we were supposed to find to resolve the question into partial fraction. Now replace it to get the final answer. So our final answer will be, it is originally 5x minus x squared over 2 plus x squared times 1 plus x will be resolved into, we are just putting the values in 1, right? If you put it in 2, then it will be wrong because we sorted out the simplification of equation number 2 from equation number 1. So we can go only uh, to replace the value of ABC here accordingly, right? Otherwise coefficient will be jumbled up. So we can write for the linear, meaning A and C will be this. A is what? Minus 2 over 1 plus x plus bx plus c. What is b? 1x plus c. 4 divided by 2 plus x square. This is the final answer. Again, I'm telling you, be careful as you started simplifying equation 2 from equation 1, not from this equation star. I can take a star. So if you take star, then the shifting of the coefficient will be different. You got my point? I hope it is clear. So as we took it from here, but you can do in any method, the answer will be right. It will not be wrong. But from the method that you either you are starting from the star equation or from one, so keep one in mind and find the unknown and replace that unknown in that particular equation from where you start your simplification. I hope it's clear. Okay, good luck. Do more practice from the past sheet paper by keeping all these four cases in mind, and inshallah, the question will be solved.